Morning or afternoon. We're trying something new today. I thought if you couldn't see my pretty face when I'm in front of you, maybe if I recorded myself and did some math in front of you this way, you'd still pay attention to get the job done. Pause for your laughter. What you need to have is this packet. It's lessons 9 through 14. And hopefully you check the black table or the side of the room and you're able to grab your copy. Go ahead and put it in your binder. This is the rest of topic B. You just had the topic B test or mid topic B that was after lesson 8. And we're going to continue talking about specific details from what that test was covering. Lessons 9, sketch a graph of a function, and so on. And some of it will be review. Some of it will be new learnings, and it's all based around the concept of function. And you can see me down in the corner there. So, hi. All right. I'm going to go ahead and start writing with lesson 9. And you can pause the video anytime you need to and go back and copy things or whatever else it needs. I'm also going to use Desmos, and so that's why I've got this queued up right here as best as I can to do some certain things. And just before I get started, I want you to know that this notation, f of x, is going to be used frequently. Already you can see it in one of the questions that I intend to use it on. And so f of x equals is going to be used in our Desmos conversation. It's really good to get to know that this notation exists. All right, enough talking. So in the entry task, to indicate whether a statement is true or false, for the function y equals 2x plus 1, y is the independent variable, that's false. It's false because this function, this y equals, depends on whatever x is. So y is the dependent variable. Next line, for the relation 2x plus y equals 5, y can be expressed as a function of x. This idea here of as a function of x, worthy of a highlighter, is that the of a function of x means that y equals f of x. And that's absolutely true. We're able to take this equation, 2x plus y equals 5, and solve for y and get a true statement. That means that y equals is on one side and everything else is on the other. For the relation 3x plus 0y equals 4, y can be expressed as a function of x. That's not possible. If you try to solve for y, first of all, the fact that there is a 0 coefficient of y means that this term cancels out. So how do you make the equation look like this, y equals, when there is no y? Because it canceled. This actually is a vertical line, so let's bring in Desmos as part of this equation. If I type 3x plus 0y equals 4, you can see that I have a vertical line at approximately 4/3. Yeah, 1.333 repeating. So when you have a vertical line and you graph it on Desmos, you can see that the vertical line test fails, and therefore you do not have a function. Y is not a function of x. For the fourth line down. So fourth line says y equals negative 12x plus 3. Yeah, that's absolutely right, that y and f of x are the same. We're making it clear that you can just swap those. I mean, the fact is that y equals f of x, so that's a true statement. All right, let you do the last one. You get to number 5. You can talk with a neighbor. You can pause and think about it, and then I'll move on. All right, that should be enough time. So a function can be represented in at least 4 ways. And we'll make sure that lessons 9 through 14 really study these 4 ways: graphically, symbolically, in table form. It's also, I'll say that as the word tabular from time to time, and verbally. And like this, the rule of 4 for functions. It's really good to be able to understand how a function works if you can understand what it looks like as a line on a graph. What symbols it typically uses, what's the structure behind them, like standard form of a linear equation versus slope-intercept form of a linear equation versus point-slope form of a linear equation. Other functions have the same structure like that. In table form, which is part of our work today, and then last of all, verbally, being able just to literally describe how the independent variable x is modified and changed. Transitioning from a function in table form or representing with symbols into a graph is an important skill. So let's consider this function, f of x equals. Desmos is going to be our friend. F of x equals 3 times 2 to the power of x. Now this is called an exponential function. It's something important to write down. I'm going to highlight it and then make sure that I comment on it. Right, it's an exponential function because we have the x, the unknown variable, in the position of an exponent. Not really trying to step outside the box in terms of naming things, but an exponential function is a very important type of function or classification of function to know about, and it gets its own name, and sometimes names are obvious. But you can see in Desmos that that line is curved. It's always above the x-axis. It never touches a height of 0. You're just dragging your mouse on Desmos reveals that you always have a positive y coordinate. No matter how far to the negative you go, you always have a positive y value, something like 0.031 or 0.012, or it just stays, look at that one, 0.005 is a y coordinate, but it's still positive, so it's still above 0. The nice thing about Desmos is that if we're going to answer the first question, we're going to fill in this cell right here. If x is -2, well, that means that in the function, we plug in a -2. And you can see from, I'm pointing at the screen, I'm using my mouse. You can see from Desmos that when you use a -2 in the function for f of x, you get 0.75 as your answer out. Okay, I wrote it off to the side for a reason, which you can see right here that I wrote it off to the side for a reason, and that's because I want to show how the 3, the 2, and the x, well, the x is the problem. So I'm going to make the 3 times 2 to the power of -2. And if you just evaluate that, 3 times 2 to the power of -2, we get that same answer. That's really what's happening here when you evaluate a function. Whatever is in the x spot on the graph, we're going to go ahead and put where x is in the function, and then that'll autofill it in the other side because Desmos is nice like that. So f of -1, 1.5. F of 0. Hey, that's familiar. In fact, notice the structure. The 3 is the y-intercept. So if x equals 0, we have 3 being the y-intercept, automatically fills in the space. If you use a 1, I left the 0 there, but it's okay. 0, 1 is the same as 1. So it's a 6, and then 12. 12 because 3 times 2 to the second power is 12. Right there, can you see it? Okay, so we're going to use that idea all the way through, that you have a function, you have an x, and you have its dependent y value, and y is the same as f of x. The reason for f of x is that the function depends on whatever your independent value is. Here we had a list of independent values, and then the outputs were what we got back from those values. Cool? Okay. So I'm going to finish this page, and then I'm going to finish the recording. I'm kind of doing like a mic test as well, just to see how well it buffered. If I, whatever, it's going to stop after this page, and then I'll ask you to click on the next video or to follow the link. I mean, please, I don't need the views. What I really just want to do is help you out with math. Okay. So to graph the ordered pair on the table, I'm going to recommend using the x-axis or the x column. So I'm looking at the page with you. This x, which has 0, 2, 3, and 5 to help scale the graph that's given to you on the page. We should also label. We don't really use all of these letters, but I really like to use the letters tails plus, T-A-I-L-S plus, to remind you to do 6 things. Yeah, 6 things when you graph a table or an equation, or you have a workspace that you're supposed to do. T for title, there's no context to this problem, so the T doesn't matter. But the A, we should label the axes as X, good job, Jeff, and Y. We should label or choose an interval that we're going to space, kind of count boxes, or know that we're going to go every box represents a 1 or a 2. There's a lot of lines out here, so I'm going to do a little quick double check. If I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I got to go to 5. Yeah, I'm going to go by ones. 1, 2, 3, 4, 5, 6. The graph space that's provided for you doesn't really let me skip boxes around, but label. So interval is from 0 to 5. From 0 to 5, and then on the y-axis, so I labeled my y-axis, and I'm going to go from, I guess, 0 to this highest number to 13. Probably going to go by ones. Let me just quick count before I actually write it in. 1, 2, 3, 4, 5, 10. Yep, so going by ones from 0 to 15. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 10. 1, 2, 3, 4, 15. Okay, your graph is ready. Plot the points. I guess I'll do 13 and you do 14. Okay, 0, 3. And I don't know what the 1 number is, but we can go back and find that in a second. 2, 7. And 3, 9. Looks like a nice straight line. 5, 5. That's not a 5. That's a 5. And 13. 10, 11, 12, 13. There's nothing indication. No, there is. There's. Okay, so as I was kind of pausing as I was thinking about this one, assume the functions are continuous. To assume the functions are continuous, that means there's a straight line that connects the points. If we didn't have, worth a highlight, if it didn't have this sentence right here, there would be nothing to convince us to draw a line through the points. Continuous means you put your pencil on the paper and you draw your line and then you're done. So that's what I'm going to do. I have a straight line. Do the best I can. Straight line. Yeah, nailed it. Okay. Please do the same for the next one. I'm not sure that it's going to be a linear relationship, but do know that whatever sort of pattern of lines that you plot over here, that it's going to have to follow or has to be connected with a smooth curve. That's the other way to think about it. Connected with a smooth curve. All right, that's it for the first half of this video. Go ahead and do number 14, and then I will start the next video with page 2.